Good day, Sir Janus. Good day, everyone. My name is Ariscon Cedric, and today we will be presenting our library management system, a program developed using Java and object-oriented programming principles. And yeah, so we used the single responsibility principle and as well as the keep it simple, stupid principle because we like to keep it very minimal and very readable for future programmers that are working with the library management system. Well, I mean, it's not really scaled to that degree, but best practices. And yeah, the goal of this system is to simulate how a small library manages its members, library items, and borrowing transactions. The program allows the library to register members, add items to the catalog, allow members to borrow and return items, and keep track of item availability. And as well as the system actually removes the members, removes members actually. And yeah, I will be explaining some caveats later on. And our system is composed of three main classes. So we have the library member and the library item. And of course, we do have a main class wherein that would be the class wherein we would run our test cases. We're going to use the these classes over instances of these classes and see see for ourselves that the relationships are actually functioning as is. And these classes instead interact with each other through associations, meaning they work together without using inheritance. I mean, our group sort of debated as to how we would implement this. The library item, like maybe we would have like the concept of inheritance, wherein we do have objects, classes for books, magazines, newspapers, and that would be extended otherwise, something like that. But then again, that would result in a higher heap memory overhead. Okay, on a higher heap memory overhead and as well as cognitive overhead because we have all these sort of branches for the types of library items. I mean, we could just use the string, which is very simple, and as well as it's less memory intensive. So yeah, looking at the class diagram over here, we have the three classes as I mentioned earlier. First we have the library class, which maintains a collection of members and library items. So we don't really have like a hard limits over here. So technically, the library can have an infinite number of members as well as an infinite number of library items. Hence, the multiplicity of zero to many. And of course, yeah, zero for the multiplicity is that the library can have no members and have no library items. This is to make it a much more free and decentralized sort of design, so that the three classes can exist without the other. Okay, and then okay. So I'm not really gonna go into detail as to how we're gonna implement all these methods, but what I would say is that all of these have public access modifiers. Technically, we don't really use protected or any sort of other access modifiers. I mean, technically, we could use like the default package access modifier, but then again, it's much safer to actually use public in this case. And yeah, the use of Codiva is very limiting compared to actually using an IDE like maybe Eclipse, IntelliJ, and Visual Studio Code when it comes to structuring your actual code. And yeah, and library exists for only one. Of course, there's only one instance of library that catalogs and manages the members and library items. And now we will be and I will be discussing now secondly, the member and library item classes. So they have a borrowing relationship and a returning relationship, wherein member has a list of borrowed items, hence the multiplicity of 0 is to many. So technically, a member can have no borrowed items, like they're just a member of the library. They didn't really borrow books. But then again, they can sort of borrow items infinitely. I mean, technically, we could like put a hard limit as to like the member can only borrow like 5 books, but the case scenario doesn't really explicitly state that there should be a hard limit when it comes to the borrowed items of the member. And yeah, to keep it very simple, to keep it very free. And like the library item, of course, having a member reference wherein it could have a borrowed where borrowed by, because as you can see here, the privated borrowed by member could be null, or it could have an actual member object being stored into it. Now there is a reason why we're using a bidirectional association over here as compared to like using a unidirectional one. Technically, our group sort of thought about this, like using unidirectional relationship would actually be a lesser cognitive load to future programmers that are using the system. But there is this such case where in a library, if we are to remove a member, we don't really know what happens to the borrowed items that a member actually has. Hence, to make it much more to make member and library items not really over reliant to one another, like the member still has a hold of those borrowed items that they have borrowed, and it's like this sort of scenario in the real world wherein, okay, the library sort of removes this member, but then again, that member didn't really return all of those books that he or she had. So that is one interesting caveat over in this program, and hence why our original implementation here in the library item, wherein we had a boolean flag as to determine if the library item is being borrowed, is being replaced by borrowed by, and this is to actually have a much more smarter display, and it's to like remove the stale references in our library. Because right now, if we are to use this is borrowed in the library item, then it would just show that it is borrowed, but it doesn't really know if the borrower is still in the library. Hence, we used the borrowed by member attribute, the field over here, so that we could know that that member is really a registered member of the library, or maybe it's not. Hence, if you could see the test, if we were to run the test cases in the main class, you should see something like the lost tag over there, because we don't really know if that borrowed item is going to be returned or not in the library. But it depends on how the administrator or the manager of the library management system actually handles all those inputs. So this is a much more free of we designed this so that the programmer.
Greetings, my name is Clemeno. So now that we've seen the overall class diagram, I will now explain the member class. So the member class represents a library member. So it is a person who can borrow and return items. It has 3 private attributes: a member ID, a name, and a borrowed items list, which is a list of library items object that tracks everything the member is currently holding. You also notice you override the equals method here, basing equality on the member ID rather than the default reference check. This is important because Java's built-in collection methods like contains and remove rely on equals under the hood. So without this, the library wouldn't be able to correctly find or remove a member from its list. And now, here's where it gets interesting. The borrow and return logic lives inside the member class itself, not the library. So when a member borrows an item, borrow item method checks if the item is already taken, then calls set borrow this on the library item, registering itself as the borrower, and adds the item to its own borrowed item list. Return item method does the reverse. It calls set borrow null to release the item and removes it from the list. This is a deliberate design choice that follows the single responsibility principle. The member manages its own borrowed items. It's responsible for its own state. The library doesn't need to duplicate the logic, it simply acts as a registry. It knows who the members are, but it doesn't micromanage what they are holding. So you might wonder, what happens to a borrowed book when a member is removed from the library? So we intentionally did not force return those items on removal. Think about it from a real-world perspective. So when a member is removed from the system, that doesn't mean the physical book magically reappeared on the shelf. So the library admin would need to handle that manually. And in our program, the catalog actually reflects this. If an item is still marked as borrowed by a member who no longer exists in the system, it shows up as a lost in the catalog display. That's handled in library show catalog method. One more thing worth mentioning, you won't find inheritance in the program. We could have made book and magazine into subclass of library item, but we chose not to. Why? Because in Java, every subclass carries its own memory overhead on the heap, its own fields, its own method table. In our case, the only difference between a book and a magazine is a single string field called type. Creating separate subclasses just for that would violate the keep it simple principle. A string is far more lightweight than an entirely separate class, and the program still communicates the item type clearly. So overall, to summarize it, the member class is lean, focused, and self-managing. It owns its borrowed items list, it handles borrow and return logic internally, and it uses ID-based equality for reliable collection operations. So that will be all. Thank you. So proceed to the next presenter.
Hello, I am Maturan and I'm here to explain the library item class. So without further ado, let's tackle this. So the library item class represents any item that can be stored in the library catalog, such as books or magazines. So each library item contains several attributes, which are item ID, which uniquely identifies the item. Next one is title, which stores the name of the item. Type, next one is type, which indicates whether it is a book or a magazine. Next one is the detail, which stores additional information such as the author or issue number. Next one is borrowed by, which stores the member currently borrowing the item. So if the borrowed by field is null, the item is considered available. So method is borrowed checks whether the item is currently borrowed by verifying if the borrower reference exists. Next one is the set borrowed method. Updates the borrower of the item whenever a member borrows or returns it. So, like the member class, the library item class also overrides the equals method, comparing object based on their item ID rather than the memory reference. This prevents duplicate items from being added to the catalog. So, together, the member and library item classes represents the real-world borrowing interaction between library users and library resources. To manage all of these members and items, the system uses a central class called the library class, which acts as the registry of the entire system. So, now that we understood that, and the next part of the program is gonna focus on the library class. And that's all for me. Thank you po.
Hi, greetings, I'm Ais, here to explain the library class. This class acts as the central manager of the system. In the code, this is represented by two private array lists, members and catalog. These collections allow the library to manage multiple objects efficiently by storing member and library item objects in a dynamic and searchable structure. So the library class provides several methods to manage members with built-in validation. We have the register member method. This adds a new member to the system. It uses members that contain method to check for duplicates before adding, ensuring that no two members share the same identity. We also have the remove member method. This handles the deletion of users. This first verifies if the member exists to prevent errors. And lastly, we have the get member method. This acts as a search engine, iterating through the list to retrieve a specific member using their unique ID. Similarly, the library class manages catalog items through methods like add item, remove item, and get item methods. This follow the same check then execute logic used for the members, maintaining the integrity of the library's physical inventory. Because of its unique position, the library class acts as the registry and coordinator between members and items. This is most visible in the display methods. We have show catalog method. This iterates through the items and uses a conditional check to see if an item is borrowed. It even checks if the borrower is still a valid member, labeling them as borrowed or lost accordingly. We also have a show members method, straightforward utility to list everyone currently registered. We also have a show all borrowed items method. These methods demonstrate coordination by looping through the member list and calling each member's personal show borrowed items method to create a master report. Now that we understand how the system stores and manages data through the library class, the final step is to see how the program actually runs. While library holds the logic, the main class provides the execution, instantiating the library and demonstrating these features in a live environment.
All right, greetings everyone. My name is Joshua Balois, and I'm going to start running the test cases that is in our mini classes. Okay, first and foremost, the main class serves as the entry point of the program. That is basic knowledge that the main classes are always the entry point for the programs. All right. Execution begins in the main method, which creates an instance of the main class and calls the run method. It's basically when we make another function that creates an instance of the main class so that the program could run efficiently. It's a basic or like a good practice for a programmer or a beginner programmer. All right. Inside the run method, the program initializes a library object, as we can see, and which we will store all members and items in the system. And the program then runs a sequence of 8 test cases labeled TC1 to TC8, or as we can call test case 1 to test case 8. All right, each demonstrating a specific feature of the system. These test cases include creating library members, adding items to the catalog, borrowing books and magazines, displaying borrowed items, returning items, removing members, removing items from the catalog. As you can see, we have that functions in our main classes, or we call them from another class, right? From another object. Okay. Each test cases simulates how the system would operate in a real library environment. Additionally, the program includes a debug statement method that detects invalid operations, such as trying to borrow an unavailable item or reference a missing object. All right. There is a debug statement method. It detects invalid operations, just as I said earlier, because if ever there is a scenario where, for example, we get an object that is non-existing, for example, the magazine, and the title you wanted to find a title that is non-existing and it is a magazine, and you want to find it in the system, in the library item that is in the library, but unfortunately it's not there. So we have to have like a key scenario, or like a, how do you say this, like a method or a function that see sees the uh sees the bug in there. Because if it's a waste of resources for the system if it's try to find it, but it's not there, basically, right? Through these test cases, the system demonstrates how the library member and library item classes interact to manage library operations effect. And that concludes our presentation of the library management. Thank you so much for listening, and see you next time. God bless.